Let's go ahead and find inverses of exponential and logarithmic functions, which is each other. So we're just going to go ahead and be given a function and asked to find the inverse, which is something that we have already done in the last unit. Should be pretty easy, right? So we're going to go ahead and learn how to find the inverse of these two inverse functions. And how we do this is we will use the same process as before. We will find the inverse of a function, switch x and y, switch the inputs and output values, and then we'll use inverse operations in order to solve for a variable. Again, this is my dear friend SADMEP. Okay, we'll use that to isolate a variable. You have to be able to rewrite an exponential form in logarithmic form or logarithmic form in exponential function form. So let's go ahead and refresh our memory. An invertible function is a function f that contains the input-output pair a comma b. Its inverse will be f inverse, is how you enunciate this, and it contains the point b comma a. Since exponential functions and logarithmic functions are monotonic, again, meaning that they only increase or decrease, they are invertible. And so here's our steps. Step 1, change x to y and y to x. Step 2, use inverse operations. Again, this is SADMEP, and the notes here specifically outline step by step for you how to, like, what to undo. But I like to just, because every kind of function's different, I like to just understand that I'm going to undo, so I use inverse of whatever order of operations I'm doing, which is also in reverse, right? So always undo your addition subtraction first, right? That's what the S and A stand for. The D and M stands for next undo multiplication division. Then you'll undo any exponential base, okay? And then lastly, if you have stuff in parentheses, obviously you have to repeat those steps in there, okay? And then lastly, change your function back to y. Okay, so, or back to inverse notation. So swap out that y and put it in inverse notation. These processes are the same for exponentials or if you have logarithms, exactly the same, okay? So let's go ahead and let's jump in. The function f is given by f of x equals 2 times 9 to the power of 5x. Determine the inverse function of f. Okay, so I'm going to go ahead and I'm going to call it y is equal to 2 times 9 to the power of 5x. And I'm going to switch x and y. X equals 2 times 9 to the power of 5y. So how do I go ahead and isolate y? Well, I'm going to use, again, reverse order of operations, SADMEP. So I'm going to undo any addition, subtraction. Hey, I don't have any. So, okay, move on next. Division, multiplication. Well, I'm multiplying by 2. How do we undo that? You divide. So I'm going to divide both sides by 2. This cancels. And I now have x over 2, or 1/2 x, is equal to 9 to the power of 5y. So since I have an exponential base 9, you undo that with log base 9. Log base 9. So I'm going to take log base 9 at both sides. Log base 9. And that cancels. So I now have log base 9 of x over 2, or 1/2 x, is equal to 5y. Okay, lastly, I'm going to go ahead and I'm going to divide by 5. So now I repeat my steps, right? If you get, inside, once you undo the exponential base, the exponent, or inside the argument of a logarithm, now I repeat my SADMEP. So divide by 5, and here's what we get. We get y is equal to log base 9 of x over 2 divided by 5. And this is originally called f, so it's called f inverse. And I just want to show you an alternative form that this could be represented in. When you divide by 5, you could also see this as a coefficient of 1/5. So 1/5 of log base 9 of x over 2. Again, same in the argument. You could see 1/2 x in there. Pretty easy, right? Example 2. The function d is given by d of x equals e to the power of 3x minus 4 plus 8. Find d inverse. So d inverse is going to be found by writing it as y equals, and then switching out x and y. It should be a minus 4. So x equals e to the power of 3y minus 4 plus 8. And I'm going to use my inverse operation. So what do I do first? Well, let's get rid of this 8. Subtract 8 on both sides. that will cancel, and we get x minus 8 is equal to e to the power of 3y plus 4. And now I want to go ahead and undo this exponential base. I cannot divide by e. A common mistake students make is they'll divide by whatever this base is. No, that's not how you undo it. You're not multiplying this exponent. It's an exponent, exponential base. So we undo exponential bases with logarithms. So I take the log base e, which is the natural log, and what we get is the natural log of x minus 8 is equal to 3y plus 4. Okay? Next, now I just got to isolate y. So I'm going to use, SADMAP again to undo this. So let's subtract 4 on both sides. Subtract 4. And what we get is natural log. Be careful here. X minus 8. You took the natural log of x minus 8. So that's protected, okay? It's already wrapped up, good to go. Now I have that minus 4 on the outside, equals 3y. And then now I'm going to go ahead and divide both sides by 3. And so we get y is equal to natural log of x minus 8 minus 4 divided by 3. This could be written as, I could divide each of these by 3. So 1/3 of the natural log of x minus 8. Remember, write it as a coefficient. And then I also have to divide this 4 by 3, so negative 4/3. Okay, so there is your inverse. Okay, awesome. Okay, let's look at this practice problem here. Please go ahead, pause the video, try to find the inverse of c. Okay, the inverse, log base 3 of x plus 5 divided by 4 minus 2 is the inverse function. You went ahead and switch x and y, and then we just use inverse operations. I'm going to add 5 to both sides. Then we're going to go ahead and divide by 4 on both sides. And then we take log base 3 of both sides. And then finally, just subtract 2. On both sides. Remember that minus 2 does not go inside of the argument, okay? So, hopefully you got it. Let's go ahead and switch gears. Now let's find the inverse of logarithms. The process is exactly the same, you guys. We're given a function d, determine the inverse of d, d inverse. So I have y is equal to 2 log base 10 of x plus 5 plus 4. So I'm going to switch my x and y. 2 times log base 10 now of y plus 5 plus 4. So what do I do first? I see lots of plus signs, I see a 2 out front. So again, SADMAP. I'm going to undo addition, subtraction first, but there's 2. What do I do? Well, this is inside of the logarithm, so I'm not going to touch that plus 5. I'm going to subtract 4 on both sides first. Subtract 4, and so I get x minus 4 is equal to 2 times log base 10 of y plus 5. Now I'm going to go ahead and I'm going to get rid of that 2. So now we'll divide both sides by 2. And we get x minus 4 divided by 2 is equal to 2 log base 10 of my argument, which is y plus 5. Woo! Okay, we got a lot here. No, I already divided by 2. I don't have a 2 anymore. Get rid of that. This cancels. Okay, now I need to get rid of this logarithm. I need to free the y plus 5. So it's protecting this logarithm. How do we undo logarithms? Exponentials. So I'm going to raise both sides by its exponential base, which is base 10. So that cancels, and we get 10 to the power of x minus 4 over 2 is equal to y plus 5. Okay, and the last step, I'm going to take away 5 on each side. Take away 5. So here is our inverse. D inverse of x is equal to 10 to the power of x minus 4 divided by 2 minus 5. Now, I'm just thinking about this. Another way you could see x minus 4 divided by 2. I see that the 4 and the 2 are they have common factors, so I could reduce this. But you can't just reduce each of them. You have to divide both the x and the minus 4. So another way you would see this written is 1/2 of x minus 2, right? So 1/2 of x, or x divided by 2, minus 4 divided by 2. So 1/2 of x minus 10 to the power of 1/2 x minus 2, and then with a minus 5 on the back end. Just a possible way that you could see it written. Okay, last practice problem here. Go ahead, pause the video, find the inverse of this natural logarithm. Okay, you set the function equal to y, and then I'm going to switch x and y. So x is equal to 1/4 natural log of y minus 6 minus 2. And again, I'm going to undo addition and subtraction first. So we add 2 to both sides. Then we go ahead and I'm going to get rid of this 1/4. So I multiply both sides by 4, and that cancels. Then I'm going to go ahead and the first thing I did was I distributed. So 4 times x and 4 times positive 2 gives me 4x plus 8. You can see this here. And then I went ahead and raised both sides by base e, right? So that's going to cancel that, and we get y minus 6 is equal to e to the power 4x plus 8. And then I just added 6 to both sides. And there you have it. M inverse is equal to e to the power of 4x plus 8 plus 6. Pretty straightforward finding the inverses. You switch x and y, and then you isolate y using inverse operations. That process does not change regardless of the function. You just need to know what are your inverse operation tools. Okay? Hopefully you learned something. Give it a thumbs up to the video, like, and subscribe. See you later.